Welcome again to this presentation. We are going to start on question 1.9. Question 1.9 is saying, calculate the value of equilibrium constant K for the reaction calcium carbonate solid, which is reacting with the hydrogen to give calcium 2 plus the bicarbonate, given the following equilibrium constant. So they have given equilibrium constant for the first reaction, calcium carbonate, which gives calcium and carbonate. Another reaction is bicarbonate, which gives the hydrogen and carbonate. Also, the equilibrium constant was given. Now they want to know what will be the equilibrium constant for this first reaction, where calcium carbonate is reacting with hydrogen to give calcium ion 2 plus and the bicarbonate. So we need to see how can we proceed so that we get this equation from the two equations. You can see here we have the calcium carbonate, and here also we have calcium. Here we have the calcium in the product. We have here carbonate, and we don't have here carbonate in the product. That means here we need to eliminate the carbonate. How do you eliminate the carbonate? Of course, you can see carbonate is here, is also here. That means you need to reverse one of the equation. So how do we proceed? So if you are writing the equation in reverse, it will also invert the equilibrium expression. That means when you are reversing one of the equation, either if you are reversing this one or this one, you need also to make sure that you are inverting the equilibrium expression for the equation. Again, when you are multiplying the coefficient by a common factor, when for example you multiply 2 here or you multiply 3 here, that means you need to know that the equilibrium constant will raise to the power of that value. For example, if you are multiplying calcium carbonate equation, the first equation, this one, if you multiply this one by 2, that means this equilibrium constant it will be raised to the power of 2. Another rule that we follow with this type of exercise is that the equilibrium constant for the sum of two or more reactions, when you are summing the one or two reaction, when you are summing this reaction, for example, if this one, and you get the third reaction, which is the sum of this one and this one, in this case, the product, the reaction that you get after summing the two equations, its equilibrium constant will be equal to the multiplication of the different equilibrium constant. For example, if you want to sum this one, if you want to do the addition of this one and this one, then the final reaction that you will see, its equilibrium constant will be equal to K1 times K2. So now let's see the answer for our exercise. So we don't have a carbonate, like I was telling you, in the product and the reactant. We need to reverse the equation 2 to eliminate the carbonate. If you are now reversing the equation 2, you can see here we have the calcium carbonate, which gives calcium, so we have reverted. Then that's the equation 1. Then if you are reversing the equation 2, we need to reverse the K also. If we are reversing the equation, you can see we are reversing the equation 2. So when you are reversing, that means we need also to invert the equilibrium constant. Then you will get 10 power 10.3. So then after inverting the second equation, then we can do the summation. Then you see that the carbonate will be eliminated. Here also we are going to eliminate the carbonate. And then you will see the final equation, which will be this one. And the equilibrium constant will be this value multiplied with this one. Then you will get 10 power 4 as the equilibrium constant for the reaction that they are asking. Now let's go to question 20. Question 20 is saying, given the reaction, they have given the reaction with Kc. Then they are asking to calculate the Kc for this reaction. Like for example, if you can see the reaction that was given here, we have 1 mole of nitrogen, 3 mole of hydrogen, which gives 2 moles of ammonia, and the Kc was given. Now they are asking here we have 2 ammonia. Where do we have 2 ammonia? It's here. So that means here they are reversing the equation. Here they have reversed the equation. So they have put this one into the reactant, while in the equation that you have the Kc, it is in the product. So that means here, if we are reversing the equation, that means we need to invert the Kc. The Kc for this one will be equal to 1 over 3.6 times 10 power 8. What about this one? So this one you can see we have here the N2, so they have multiplied by 2. Here also they multiplied by 2, and here they have multiplied by 2. That means the Kc will be raised to the power of 2. It will be equal to Kc raised to the power of 2. For example, this one, because they have multiplied by 2. What about this one? For this one, what they did, so they have divided by 3 here. Here also they divided by 3, and here they divided by 3. That means when you are dividing by 3, that means this is the same as doing the square root of 3, or taking this value power 1 over 3. So it's the same, or taking the roots of 3 of this value. So let's see the answer. So this is the answer for this one. When the reaction is reversed, the Kc is inverted. So that is what we are doing. So here the number I, that's what we did. The Kc will be equal to we are inverting the Kc, we get this value. Then when we are multiplying the common factor, they have multiplied by 2 for the second equation. That means also we need to raise to the power of that value. Then you get this one. Then for the last one, so it's like they have divided by 2. It's like raising the power of 1 over 3, or taking the roots of 3 of that value. Then you get this value. Let's move to question 21. Question 21 is saying at this temperature, the equilibrium constant for the below reaction is 0.118. It was given. Then they want to write what is the equilibrium constant for each of related equation. So we have the 2 equations, and also we have given the Kc for this question. How do we proceed again? If you can see this one, 2 ammonia. So here we have it in the product, and here it is in the reactant. That means they have reversed the reaction. So if they have reversed the reaction, then we need to invert the Kc. Here also, how did they have divided by 2, here divided by 2, and here also divided by 2. So that means dividing by 2, we do the square roots, or we can do power 1 over 2. So here Kc we invert, so because they have reversed, and then here we do the square root, or we take 0.118 power 1 over 2. Question 22 is saying at this temperature, the equilibrium constant for the reaction below is this one. Then, so they have given the reaction is this one, and they have the equilibrium constant. They are saying what is the value of equilibrium constant for the following reaction at the same temperature. Let's see the reaction that was given. If you check here, they have reversed the reaction, but not only reversing, they have also divided by 2. So reversing, because this one has gone into the reactant, but they are also dividing by 2. Here also that is the same, they divide by 2, they divide by 2. That means we start by reversing. If we reverse the reaction, we invert the Kc. We start by here inverting the Kc. Then after inverting the Kc, because they have divided by 2, we do the square roots. So that's what we are doing. So we have first invert the Kc because they have reversed the reaction, and then we do the square root because they have divided by 2. Then we will get Kc, which is equal to this value. Let's go to question 23, saying the following reaction occur at this temperature. We have this one, then they are saying calculate the equilibrium constant for the following reaction at the same temperature. So which one do they ask? This one. If you check this one, so we have the calcium monoxide, the CO, it is here in the reactant, here also it is in reactant. 2H2, it's in the reactant, here also it is in the reactant. Then CS2 is also the same in the product and water in the product. So we see here, we'll see whether we can add this one. So we will cancel this one and this one will remain, but we cancel this one. This one is the same. We'll see how to cancel this value so that we can add them. Then we get the case. If we are adding them and we get this equation, that means in this case we are taking the K1 multiplied with K2 as the overall K for the reaction. Let's proceed. This is what we have. So this we are cancelling the hydrogen because here it is here also it is there in the product, and here it is the reactant. We can also cancel it. Then what do we cancel again? We can cancel the methane. So we also cancel the methane. Then what will be remaining? Will be remaining for this overall reaction that was asked. Then we will take the K1 times K2 so that we get K3. Question 24, they are saying the first of two steps in the industrial synthesis of sulfuric acid, elemental sulfur, reactive oxygen to produce sulfur dioxide. In the second step, sulfur dioxide reacts with additional oxygen to form sulfide. The reaction for each step is shown. Here they are giving us the step 1 and the step 2. So they are giving us the Kc, and then they are saying calculate the equilibrium constant for the overall reaction below. So the overall reaction also was given, and they are asking to calculate the equilibrium constant. Here, if you have the two equations that was given, and then you have to calculate the overall, in this case, you need to see how do you eliminate some of the parameters so that you get this value, this equation. So here we have this one, it's also here. Do we have this one oxygen in the reactant? Yes. And you have the SO3 in the product. Here also it is in the product. So let's proceed. How do we proceed? So the overall reaction is this one. Then you see how do we cancel this one? There goes with this one. Then in this case we get this value because this oxygen plus this one will be equal to 3/2. Then key overall will be this one times this one. Let's go to question 25. Question 25 is saying determine Kc at this one for the reaction. You have the reaction here given the following data. So what is the data that was given? That is 1, that is 2. Now we have the 3 data, and now they are asking to calculate the Kc for this reaction. So we need to make sure that we get this reaction. Let's see how do we proceed. Here we have this methane is in the reactant. Here also it is in the reactant, but here we have 2. That means this one we need to multiply by 2, multiply by 2, multiply by 2, multiply by 2. But that means we need also to take Kp raised to the power of 2. Again, what you need to know is that they are asking the Kc. After getting the Kp for the overall reaction, after getting the Kp for this one, then you will use the relationship between Kp and Kc to calculate the case. Let's first calculate the Kp for the overall reaction. So then the next we have C2H2. C2H2 here, it is in the product, but here in this question it is in the reactant. That means we need to reverse this reaction. This reaction should be reversed. That means after reversing, here we are going to invert this Kp. After inverting the Kp, but here we are reversing, but here we have the C2H2. So that means here also we need to divide by 2. So we are reversing and also dividing by 2. That means this Kp also we will invert and do the square root. Then this one, how do we proceed with this one? So you can see here we have 3H2. So that means if you have the 3H2 here and here we have H2 here, you can multiply by 3. Let's see, let's try. So that's what all this word, that's what I was saying, that finally to eliminate the water and oxygen, we need to multiply by 3 in the equation. Let's try to see if we can get the answer. For this one, we said we multiply by 2, the Kp also we raise by 2. The second one will be inverting, and then we'll be doing the square root, we get that one. Then the third one multiply by 3 and we get this one. Let's see whether we can eliminate and we try to get the same answer. The same way it goes. The water, this is 2 water molecules plus 1, that's 3 water molecules. They goes together with this one. So then here we have the 3 over 2 oxygen, and also here we have the 3 over 2 oxygen. You also cancel them. Then that's the equation that we get, the final equation. Then we can get the Kp. This value of Kp it was obtained by multiplying this one to this one and this one. That means the product of this one multiplying this one, multiplying with this one. Then you get the Kp is equal to 1 over 1.83 times 10 power 89. Then after getting the Kp, you can use the Kc. Of course, we need to change the number of mole. Here we have 1 mole plus 3 mole, that is 4 minus 2. That means we get 2 mole as the change of number of mole. Then Kp is equal to Kc RT power the change number of mole. Here this one we have is 2. Here we get the constant. Here also it was given the temperature. Then that we can calculate the Kc because we have Kp, which is here. So let's do some of the rearrangement. Then we get Kc is equal to Kp over RT, change the number of mole, the gas constant, the temperature, and then finally we will get this value as the Kc for the reaction.